Hello friends, welcome back. In this tutorial, we will study about link state routing. It is a routing algorithm. So first of all, consider this internet. In this example, these clouds, they represent local area network. And the number inside each cloud is that local area's network ID. So the network ID of this LAN is 55. These LANs are connected by routers or gateways, which are represented by boxes, as you can see here. Right? Now, the packet cost. In link state routing, the cost is a weighted value. The cost is labeled on arcs. As you can see here, the cost is labeled on arcs. Cost of hop is applied to each packet as it leaves the router and enters a network. As you can see here, if a packet leaves this router and enters this network, then what will happen? The cost will be 1 unit, as you can see here. So the cost is applied only to the arc from router to network, and the cost of the arc from network to router is always 0. So as you can see here, the cost is applied only when packet leaves a router and enters the network, right? So when a packet leaves a network and it goes to the router, then in that case the cost will be considered 0. See, in a link state routing, each router shares its knowledge of its neighborhood with all routers in the internetwork. Each router sends the knowledge of its neighborhood to all routers through link state packet. Now see the structure of link state packet of router A. So see, first of all, that router A, it has 3 neighbors B, F and E. So both A and B are having direct link with network, having network ID 14. So this is the structure of a link state packet which is sent by router A to all the routers in the internetwork. Now see the format. First column is advertiser. Advertiser means who is sending this packet. This packet is sent by router A. So in this, all the entries will be A because this packet is sent by router A. Now second is network, third is cost, and fourth is neighbor. See the first entry. First entry, it shows that this router A, it is connected to the network 14, and cost of sending a packet from router A to this network 14 is 1 unit, right? And its neighbor is B, because A and B, they both are having direct link to network with network ID 14, so its neighbor is B, right? Similarly, see the second entry. In second entry also, advertiser is A because A has sent this packet, and it is having direct link with the network ID 78, and cost of sending a packet from router to the router A to this network whose ID is 78 is 3, and its neighbor is F because both A and F, they both are having direct link with this network whose ID is 78. So this is the link state packet which is sent by router A, and router A will send this link state packet to all the routers in the internetwork. So every router receives every link state packet and puts the information into a link state database. Because every router receives the same link state packet, every router builds the same database. Here you can see that every router will build a database like this. So this is the link state database for our example which you have seen. For it is a link state database for this example, right? So for this internetwork, in a link state routing algorithm, each router will have this link state database. So once every router has its link state database, then whenever a router has to send a packet, then the router will apply Dijkstra's algorithm to its link state database. Dijkstra's algorithm is a single source shortest path algorithm. So if you want to study about Dijkstra algorithm, you can study my video in it is given in the playlist of design and analysis of algorithm. So this Dijkstra algorithm, it calculates the shortest path between 2 points on a network using a graph. So here graph is made up of nodes and arcs. So in this case, the nodes are of two types, networks and routers. So once the router is having this link state database, then it can consider the whole internetwork as a graph, right? And the nodes of that graph will be the networks and routers, and arcs are the connections between a router and a network, and cost is applied only to the arc from router to network, and the cost of an arc from network to router is always zero. So by using once this link state database is formed for each router, then a router can use Dijkstra's algorithm to find the shortest path from that router to the destination where it has to send the packet.